Today we're going to be connecting problem 1.1 to 1.2. Before we get started, I'd like you to have your packets opened up to page 9. And I want you to just find some blank space, maybe on the bottom of page 8. And I want you to sketch what this picture looks like. What I'm going to do is I'm going to show you two different expressions that could represent the border tiles around the pool. And I'm going to have you prove to me if they are equivalent. Okay, so here I have a pool with a side length S, and we talked about yesterday that if this was S feet, I would need S number of tiles, because each tile is a foot by a foot. Okay, so because it's a square, I need S tiles here, here, and here. Now, so we don't stub our toes, we need to include our corners, so I need an additional tile here, an additional tile here, here, and here. Now, a lot of you yesterday wrote the expression 4S plus 4 to represent your number of tiles, meaning that I would need 4 groups of S number of tiles plus my 4 corners. I'm going to show you two different ones, and I want you to prove to me that they are 4S plus 4, or equivalent to 4S plus 4. Have me check it, and then you can start problem 1.2. Okay, I am going to draw in S plus 2. So S plus 2 would be a side, or an S number of tiles, plus 2 of the corners. So if I kind of highlight in this, I notice that I'm going to have 2 of those identical groups. Okay, so I'm going to put the S plus 2 in parentheses and show that I have 2 of those. I have another up here, a side and 2 corners. Now I'm not done considering all tiles around the pool. I have a side here left, or S number of tiles, and another S number of tiles here. Okay, so this would mean that I would have to add on the 2 more groups of S number of tiles. Okay, so here's the first one you're going to look at. The next one I want you to look at is, let's see if I can erase some of this quick. Let's get the pool back up here. And let's get S tiles, 1, 2, 3, and 4. And let's get our corners back. So 1, 2, 3, and 4. Okay, so let's draw in our little waves for our pool. Okay. Alright, let's think of another way I could break this up. Maybe we want to just group together a side and 1 corner. So I would show that that group would be a side, or S number of tiles, and just 1 corner. Well, now I got to figure out how many of these exact groups do I need to surround the whole pool. So here's another side and 1 corner, so I'm up to 2. Another side and 1 corner, so I'm up to 3. And it looks like I'm just going to need 1 more side and 1 corner, okay, to surround the whole pool. So this would mean that I would need 4 groups of a side and a corner to surround the whole pool. Okay, so what I would like you guys to do is to take these two equations, or expressions, so the first one being 2 groups of a side plus 2 plus 2 sides, and 4 groups of S plus 1. And I want you to show me algebraically, so simplify both of these and prove to me that they are both equivalent to 4S plus 4. Once I have checked your warm-up, I would like you to be looking at page 9, okay, and I'm going to help you get started with problem 1.2. Okay, so in 1.2 we have Takashi reported his ideas about an equation that relates the number of tiles needed to the side length of the pool. Okay, so he kind of visualized the pool as needing 4 groups of S tiles and his four corners. He visualized the parts individually to help him write an equation that would relate n number of tiles to the side length of the pool. So when I look at this, I think about how he thought the number of tiles would be equal to 4 S's. So I'm just going to show 4 groups of S plus 4 individual tiles, so plus 4. There's 4 other students in his class. They each came up with different equations for counting the number of border tiles. Okay, so for each equation, you're going to sketch, just like Takashi did up here, what they are representing in their equation. The tricky thing about this is you need to remember that if it's in parentheses, it means a group. Okay, so we know from our warm-up that this is 4 groups of a side and a corner. So the first thing I'm going to do is sketch a side and a corner. Now because I want 4 of these groups, I'm going to show that I'm going to add it to another side and a corner, plus another side and a corner, plus another side and a corner. Okay, so we're going to check to make sure that all 4 sides and all 4 corners are included, which I can look and I can see I have 4 boxes labeled S and 4 single tiles for the 4 corners. Okay, but instead of showing them all separately, Stella thought of them as a group of a side and a corner. So what you're going to do with your partner is you are going to sketch for Jerry's equation, Hank's equation, Sal's equation. Then you are going to determine who is incorrect. Okay, so one of those equations is not equivalent to the other, and you need to be able to tell me why. Have me check it at this point. Then you're going to go through part B. Part B is going to have you check equivalence by plugging in a side length of 10 feet. So this means if I had a pool with a side length of 10 feet, I would need 10 tiles to just surround that one side of the pool. Okay, so all I'm going to do is plug in 10, and I'm going to simplify to figure out the number of tiles. You're going to do that for Stella, Jerry, Hank, and Sal. Okay, you are then going to check to see if the same person running out of room is still incorrect. Then it says which expression for the number of border tiles in question A represents Takashi's sketch. So basically it's saying which of the 4 classmates thought of breaking up the tiles the same way Takashi did. And when you get to 1.3, you are going to stop. You're going to turn to page 32, and that is going to be your ticket out the door. So 32 is going to be what has to be starred by the time you leave today.